morning. Howdy, y'all. Welcome to another fabulous episode of How Many Tabs Are Open on Mr. Johnson's Computer? And because of today's exercise, one, because I needed to do this half and half screen thing. So I'm going to try to copy the graph to my little note paper over here. And it did not work. So we have one tab. Today's an asynchronous day. So, if you have any questions, ask your teachers, blend message them. We're here for you, even if we don't have our whole group class. So let's go ahead and get started. So today's assignment, the first one you have is an engage. It's basically doing exactly what we did yesterday. So you're taking a graph, you're making a table from the graph, right? So remember, whenever we're trying to find a rule, right? A rule is like x plus 2 equals y. That's like an additive rule. A multiplicative rule might be like 2 times x equals y. So basically, we're looking for an additive or multiplicative rule when it comes to this table or this graph. Now, finding a pattern on a graph is something that you'll be able to do for sure one day just by looking at the graph. All right. But right now, since we're brand new to this, looking at the graph does not necessarily give us the rule right away. All right. However, we have been working with something that gives us the rule right away, which was the table. All right. So let's, in fact, just make a table. Remember, we have X and Y on our table. If you want to label it even more, you have an input and an output. Okay, so your input means run, and your output means jump on your graph. So we are going to find all of the ordered pairs on this table, and we'll put them on a graph. Actually, I don't know why I made 4 because we only have 3, but that's fine. Okay, so our first ordered pair is our blue dot. So let's just use a blue pencil. All right, so blue dot over here. It's in a very special place. It is at the ordered pair 0, 0, which we also know is called something special. So if you remember from a couple weeks ago and just using these skills over and over, 0, 0 on the graph is called the origin. So right here, that is the origin, 0, 0. And you can put a point on the origin. That's exactly what they did. So they ran 0 on the x-axis. Remember, if you're looking at a graph, this part is your x-axis, this part is your y-axis, and then that's your origin. All right, so they ran 0 and they jumped 0. Their ordered pair is 0, 0. Okay, so let's go ahead and move to the red dot. So we're going to run on our x-axis. You ran 1, and then we're going to jump on our y-axis. We jumped 3. All right, so we have the first 2 points. Now let's do the third point. Hopefully it changes the color to green. I'll give it a second. All right, so now let's do the third point. So we're going to run on our x-axis. 1, 2 spots on our x-axis, which is our input, x-axis, input. And then we're going to jump all the way to the 6. So on our y-axis, we're at the 6. So our final ordered pair is 2, 6. All right, we have 1, 2, 3 points. We have 1, 2, 3 pieces of data. All right, so now we have to find the rule, right? So we're going to try and find whatever the rule is by figuring out what is the pattern that we could figure this out with adding, and what is the pattern that we could figure this out with multiplication. All right, so 0 turns to 0. This one's really hard to start with because 0 turns into 0 in so many different ways. 0 plus 0, 0 times 1, 0 times 2, 0 times 3, 0 times 0. There's like an infinite possibilities of ways to make 0 with multiplication. So if you have a data table that starts with 0, 0, go ahead and move to the second piece of data. All right, so now we need to figure out how can we turn 1 into 3 using addition, and how can we turn 1 into 3 using multiplication. All right, so 1 turns into 3 by adding 1 plus 2. So if we added 2, we would get 3. Where 1 turns into 3 using multiplication by multiplying times 3. So 1 times 3 is 3, 1 plus 2 is 3. So both of these could work with this set of data. But now we have to figure out if it would work with this set of data. So what we're going to do, 2 plus 2 is 4, which is not 6. So plus 2 does not seem like a good idea. And then 2 times 3 is 6. So it looks like times 3 works with both of those. Now think about this one. If we did 0 plus 2, we'd get 2, so that's not going to work. And if we did 0 times 3, even though it's times 3, we're multiplying times 0, so it's still going to be 0. So our actual rule looks like times 3. That's like our 3rd grade, 4th grade rule, right? But now we need to remember, what times 3? X times 3. 3 x's equals a y. So let me show you how this works. So let's say that I do 3 times my blank equals y. I can plug in these numbers and they will all check out. 3 times 0 is 0, so 0 equals y. If I want to try with 3x equals y, and then I'm going to replace the x with the 1 from over here, equals y, then 3 equals y. That did check out. Final one, if I'm using 3x equals y, and then I replace the x with our box in parentheses for multiplication, and if I put 2 in that box, because I have a 2 over here for my input, then 6 equals y. That does check out. So the rule would be 3x equals y, and that is a multiplying rule, so we call that a multiplicative rule. All right? So if you're using the stems, which you should, because if you want full credit for this assignment, you use 4 stems. 3 stems is not using 4 stems. 2 stems is not using 4 stems. 1 stem is not using 4 stems. The 4 stems are I notice, and then tell us what you notice. They are the same. Tell us what are the same. They are different. What are the same? And the pattern is, and I just told you, the pattern is multiplicative. So let's go over these. I notice we're looking at a coordinate grid. I notice we are looking at a coordinate grid. I notice we are looking at a coordinate grid. All right, they are the same. The scale for the x-axis and y-axis are the same. They both skip count by 1. So the scale on the x-axis and y-axis are the same. You could say that the points follow the same rule, because we figured that out by doing the table and finding out that all 3 points worked with 3x equals y. So you could say they are the same because they all follow 3x equals y. They are different. They are different. I would say the biggest difference on this one is that you have graphed on the origin, and graphing on the origin, it's really hard to find a rule for. All right. They are also different because they are in 3 different places on the graph. So they have 3 different ordered pairs. They have 3 different coordinates. So let's use that, not their 3 different colors, because usually on graphs, they're not going to use that many different colors. So they are different coordinates. They are in different locations on the coordinate grid. They have different y values. They have different x values. All right. And then finally, the pattern is, we figured it out, it's a multiplicative rule. 3 times whatever our x number was, 3 times whatever our x number was, equaled our y number. All right, so use all 4 stems, once again, to receive full credit. And after that, you have a play posit for math. So remember, for some reason, the play posits, like once you complete them, you get like the little X on my side. So it might not cross off your calendar, but I will get to see that you have completed it. So if it doesn't cross off your calendar, that's fine. But like if it's not completed, it will still show up incomplete on my side. So the calendar part is weird. So if play posits aren't crossing off your calendar, as long as you've completed them, your teachers are getting that signal from Blend. I don't know why it's not crossing out though. So I think that's it. So please let your teachers know if you have any questions. We're around all day. Just Blend message us and all that. So I hope you have a good day. Like and subscribe if you feel like it, and definitely do your best. and have a wonderful day. I'll see you later. Bye.